Assalamualaikum and hi. Today, I myself with my team will represent our project, which is a green energy incubator for subject Bmmh 2413 has Hvac design project. Our supervisor, also our lecturer, is Dr Muhammad Zulkarnain. Okay, this is our team. So let me introduce them. First, we have Doloryen, Danello, Tegong, Binti. His task to design project, execute project, program project, test and simulate project. The second is me, which is Nuryn Binti Yatim. My task is about record data and schedule meeting. Our third member is Sasitaran Varathajoo. His task is about project advisor. And lastly is Wei Xiang. His task also as a project advisor. So for this presentation, we will explain about the chart, introduction, problem statement, objective, scope, flow chart, lesson review, bill of material, project cost, simulation, test run 1, incubation process, test run 2, final product, and conclusion. So as you can see, this is our automation chart, and this is for our Gantt chart for our team. So first we go to the introduction for green energy incubator. So incubation is the process by which certain egg-laying animal hatch their egg. It also refers to the development of the embryo within the egg under favorable environmental conditions. Multiple embryo factors are vital to the incubation of various species of animals. Many species of reptile, for example, no fixed temperature is necessary, but the actual temperature determines the sex ratio of the offspring. In the birds, in contrast, the sex of offspring is genetically determined by numerous species. A constant and particular temperature is necessary for successful incubation. So incubation period, the time from the start from 11 days to the active days. So in this letter, the incubation is interrupted. The longest uninterrupted period is 64 to 67 days. Embryo development remains successful as expanded until the onset of incubation. The freshly laid eggs of domestic fowl, ostrich, or several other species can be stored for about 2 weeks when maintained under 5 degrees Celsius. Next, we go to the problem statement, which is problem on which we will study and solve for the project. So we have two problem statements, which is a test renewable energy hubs with evolutionary in farming industry. The second one is how microcontroller technology can be used in chicken farming industry. Next, we go to the objective, which is the objective of the project Green Energy Egg Incubator. So first objective is to build the incubator with automatic controlling the humidity and temperature. A proper control means that the temperature or humidity is too high or too low for a sufficient length of time that it interferes with the normal growth and development of the embryo. Poor results also occur from improper ventilation egg turning and sanitation of the machine or eggs. Second, to build the incubator that able to incubate various types of egg, making an egg incubator that user-friendly will produce more valuable production and available for many types of egg using solar panel. Next, we go to the scope. To state the scope of the green energy incubator. So our scope is design green power system and hardware for egg incubator with automatic control the temperature and humidity using programmable interface controller, which is PIC, and solar panel according to types of egg and parameters given by user. So next we go to project, work of the executive of the project. So first we do project idea generation, which is we sit in one group and we discuss for our idea project. Second, we grading and selection of the best idea. So first, we decide to make a cap solar panel or which is a cap for workers on the site. After that, we go to our supervisor proposing the opinion to the supervisor. Our supervisor was agree about the idea, and we continue with the material. Next, create the new project idea. After we proposing the idea, which is a cap solar panel, we found out that it have some difficult to continue that project, so we discussed and we decide to change the idea, and we changed the first project to the current project, which is a green energy egg incubator. After we decide and we all agree about the new project, and we decide go to our supervisor back to ask his opinion, and he also said he's agree, and we continue to buy all the parts for the product and create a drawing or sketch based on the project. After that, we buy all the things and drawing the project, a sketch project. We finish the project using we make a project using the sketch or drawing as a guideline. After that, project testing and commenting. So next we go to the assembly view, which is the green energy egg incubator views. Okay, as you can see, we have a front view, side view, and the top view for the green energy egg incubator. And lastly, this is isometric view for our design for green energy egg incubator design. Okay, I will pass my this presentation to next member. Thank you.
Next, after the assembly view, we are going to look into the green energy egg incubator build. First of all, this is the component that we use for our green energy egg incubator. Okay. Next, we are going to look into the component that we are using for this project. First of all, we are using photoresistor. to detect the light. Next, we are using the relay switch to turn on and off the electrically. Next, we are using the Arduino Uno as a brain for our project. Then we are using the lamp holder to hold a bulb, and then we use a bulb to heat up the container inside. Then next, we are showing the 5-volt air cooler which used to cool down the air inside the container. Next, we are using the solar panel to store energy, and then we use the lithium battery 3.7 volt 250 milliampere. We also use the lithium battery charger to charge the battery. Next, we are using the cable 1.5 mm to connect between components. We also use resistor to prevent overload. Next, we are using the digital thermometer which used to measure the temperature inside the container. Next is the heat shrink tube. Then we also use the water bottle to store the egg, and we also use the coconut husk to prevent the egg from breaking.
Hello, my name is Sasitaran. Now I am going to explain about the project cost to build the green energy egg incubator. So we can see all the list of components we used to build the green energy egg incubator. So we use the solar panel, one lithium battery, one 5-volt dual relay switch, one 5-volt DC cooler fan, and one lithium battery charger, one Arduino Uno R3, one digital thermometer, one light bulb and lamp holder set, and two resistors, that is 1 kilo ohm and 220 ohm, and light resistor diode, that is LDR for light sensor, and we use other material, that is screws and door hanger and everything. So the total cost is around 180 ringgit and 99 cents.
Okay. Next, we are going to show you the stimulation for our project. So the stimulation that we done is 1 meter stress and thermal. Okay. First of all, I'm going to show you the 1 meter stress for the body. So for the load and fixtures, the fixtures detail we use one phase, and the type of fixture is fixed geometry. So the result is the resultant force for X is 9.99974. For Y component, which is 1.9961 E minus 0.5, and then the Z is negative 3.14116 E minus 0.5. Then the total of resultant is 9.99974. So next, for the force, for the load detail, we use one phase, which is shown as on the picture, and then the type of force is normal force, and the value for the normal force is. Next, I'm going to show you the stress and the displacement for the stimulation. So As you can see in the picture below here, on the left, this is the stimulation for stress, and the minimum value is 2.428 E negative 0.1 Newton per meter square, and the maximum value for stress is 8.050 E positive 0.4 Newton per meter square. As for the displacement, the minimum is 0.000 E positive 00 mm. As for the maximum value for displacement is 2.158 E negative 03 mm. Next, I'm going to show you the stimulation for strain for bottle only. The type of strain that we are using is equivalent strain, and the minimum value is 1.163 E negative 10. As for the maximum value is 1.446 E negative 5. Okay, next I'm going to show you the 1 meter stress for component box. So for the load and fixture, the fixture detail, entity, which is one face from the top to the bottom, and then the type is fixed geometry. So the resultant force, so reaction force for X is negative 0.000946.246. As for the reaction force at Y, which is 10.0053. As for Z, and the value is negative 0.00105926. So the resultant force is 10.0053. So for the load, we use the force on top of the component box, and entity, which is the one face only. Then the type of force which we apply the normal force, and the value for the normal force is 10 Newton.
And for the chapter 10, we're gonna talk about the first test run. After this, I'm gonna show you a video of our test run, and we have tested it during the daytime and how it works, and it is around 80% of our product during that time.
Okay, from the solar panel, we will charge the lithium battery. As you can see, if I close the solar panel, the lithium battery won't charge. As you will see, the LED light is not on. See that? Light is charged. And when the sensor detects sunlight, the fan will turn on. But if the sensor didn't detect the light, the relay switch will turn on the lamp, so you can heat up the egg. And if I let the sunlight go through the sensor, the lamp will turn off and the fan will turn on.
So this is our egg incubator for the first test run, and it is 80% done. We use power bank to supply the power to the Arduino, and the sunlight will charge the small lithium battery, which is 3.7 volt. And so far we haven't tested the temperature of the egg incubator since the sensor haven't arrived yet. And this is for the first one, test run, and after this we will show you the process of the incubation process. And after the incubation process, we're going to talk about the second test run. Thank you.
Next, I'm going to show you the incubation process for the second test run for the green energy egg incubator. So first of all, the chick incubation process is 21 days. We gather fertilized egg 2 to 3 days in advance. We also set up the incubator to maintain temperature of 95.5 Fahrenheit. We add water inside for humidifying purpose. We also mark an egg so that we does not confuse with the other egg. Next, the first one, obtaining and carrying of egg. So we gather fertilized egg from a farmer. An egg should be stored at a temperature of around 10 degrees Celsius until incubation begins. The egg should not be more than 5 to 7 days old. Second, we preparing the incubator. Incubator should be out of direct sunlight in a room temperature of 21 to 24 degrees Celsius. And we maintain the incubator temperature of 37 to 39 degrees Celsius. Next, we turn egg 2 to 3 times per day to prevent embryo from sticking to the shell membrane until the 17th day. Next process is candling the egg, so allow you to see clearly the developing embryo stage and dispose of the infertile eggs and or dead embryos. So at the end of incubation process, after the 17th day, egg should not be turned. Incubator should not be opened unless it is necessary to add water. All chicks which are going to hatch should be out of their shells by the 21st day.
Good day everyone, my name is Doloryen Danello Tegong Thomas from class 2 Bmmh section 1 and my metric number is B092010-240. I'm going to present to you guys about chapter 12 of our presentation, which is the test run number 2. Okay, let's proceed. For the test run number 2, we uses the thermometer to check the temperature of the incubator. Note that this was taken during the night and the temperature is 37.8 Celsius. It's a good achievement for us where the range of the egg to incubate is around 28 to 37 degrees Celsius. Okay, let's proceed to the next slide. Okay, this is our final product for chapter 13. We're going to show you guys our final product, and this is our final product. This was taken during the daytime, and the fans circulate the heat from outside surround the the egg incubator, which the insulator that we use are very helpful to gain the temperature. We use coconut husk to be our insulator, and when the fan produces the convection from the air, it circulates through the insulator, which is the coconut husk, and it could achieve the temperature that we wanted, and this is between the range, and it is acceptable for us since that's what we wanted. And next, proceed to the next slide. So this is the experiment. We uses the lamp as in replacement of the sun, and as you can see, the temperature right now is 40 Celsius, slowly degrading. And if I switch on the light and put on the sensor here, we switch on the fan, see the fan is moving, and it slowly will decrease the temperature if the fan is moving. See there, fan is moving. The fan is moving. See, the fan is moving there, and supposed to be When the LDR doesn't detect the light, as you can see in the test run number 1, the light bulb will shine to give radiance to hit the egg. But since we tested a lot of time and the TNC a lot of time, the light bulb was the light bulb was broken, and we used both of our spare, so the light bulb won't shine. But if we can see during our test one run, the light bulb did function and the fan also did function, and now the temperature is slowly decreasing, and this is not good. And that is all for our experiment. Thank you. Our final chapter would be chapter 14, the conclusion of our project. We can conclude that the Green Egg Energy Incubator could help to promote the farmers in Malaysia that green energy is cheaper, easy to get, and unlimited. It is to improve the farming industry in Malaysia, as most farmer in Malaysia uses the traditional method of waiting for the hen to incubate themselves. Thus, this could cost time and health of the egg. If we use an egg incubator, we could monitor the egg condition always. Other than that, the employment of green energy could also help with global climate changes, as by using the green energy, we could have a healthier earth, and the temperature of the globe won't be increased due to the climate changes. Furthermore, the usage of the recyclable materials for the egg incubator also reduced the cost of the materials, and it was using polyethylene terephthalate materials. The egg incubator is also portable in sizes, as it is compact. Despite that, the usage of the coconut husk for heat insulator is very innovative, as it has a great heat insulator. It is a comfortable nest for the chick to hatch. Lastly, humankind should optimize the usage of the green energy, as it is limited, environment friendly, and costs almost nothing, as we are heavily relying on fossil fuel as our main source of power supply. Not only it could endanger the climate changes, it could also finish up in the near future, since it is very limited. And that is all from me. Thank you for watching, and I hope you guys enjoy our presentation. Hope the project also could be improved in the near future, because it is very innovative, and we could have better farming industries in the future, since the global pandemic leads to a lot of shortage in chicken and eggs. So I hope our project will be innovative enough to help Malaysia in the future, and thank you for watching. We also won't forget for thank this site blogs and the people who help us during our executing the project, and this is our credit to them. And again, thanks for watching.